nothing better than watching you smile. Whoa, whoa, whoa. Ain't nothing better than watching you laugh out loud, my baby. Ain't nothing better than watching you.
Welcome. Today we're going to be discussing our last method of solving systems of equations. So let's begin. In front of you, you have notes that will follow along on the PowerPoint. Let me adjust this. Okay. Solving systems of equations using substitution. Our steps are to solve one equation for one variable. What does that mean? You want one of your equations to be y equals or x equals, or if you're not using x or y, Aubrey, you can, maybe it'll be a equals or b equals. Substitute the expression from step 1 into the other equation. And we're going to talk about each one of these steps. Simplify, solve the equation for that variable, substitute back in to the original equation to find the value of the other variable. Check the solution in both equations. So on your notes you have in front of you y equals 4x and 3x plus y equals negative 21. One of my equations is already solved for one variable. Y equals 4x. Now we're going to look at the other equation. Do you see a y in the other equation? Yes. So where you see a y, you will be substituting in what y equals. It equals 4x. Pay attention to the blue variable on the first equation, 3x plus y equals negative 21, and then in place of that y we are going to put in the 4x. Now I have in my equation the same variables, combining like terms and solving for x. X equals negative 31. Step 4 is to substitute back into either one of the original equations. Obviously, the y equals 4x will be easier, but what if we want to use the other one, okay? So 3x plus y equals negative 21. We said x was negative 3. Where you see an x, you substitute in the negative 3, the value of x, solve for y equals negative 12. Now you know what your solution is to this system. Negative 3, negative 12. Checking back in both equations. Negative 12 equals negative 12. And negative 21 equals negative 21. Let's try example number 2. Neither one of my equations is solved for one variable. Do you see that both variables are on the same side of the equal sign? We want to get one of these equations with one variable on the m1 side of the equation. Think of y equals mx plus b. Y was by itself. I'm going to choose x plus y equals 10. Thinking back to y equals mx plus b, I'm going to bring my x to the other side by using inverse operations. Now, wherever I see a y in my second equation, notice the blue. Wherever I see a y, I am going to substitute in. Now look at the parentheses. Because there is a negative or a minus before the y, I must use parentheses so I can distribute that negative x. This is probably the biggest problem area when we are doing substitution. Distribute that negative, the x becomes positive, the 10 becomes negative. Combine like terms, solve for x, substitute back into either original equation to find the value, y equals 8. The solution to the system is 2, 8. Check the solution in both equations. Okay, I would like you to try the next two on your own. Now, going back and viewing the video for step-by-step instructions would be advisable. The first set of equations, y is by itself. You do not need to move anything. You're just going to substitute in where you see this goes right in where the y is. And then you're going to solve for x, get a value, and then substitute in to find your y. Good luck.